Now consider the equation Lu is equals to 0. So here the U denotes the number of unknowns or the collection of unknowns. It represents the collection of unknowns. Unknowns are the number of unknowns in the equations like U1, U2, up to so on. And L, here the L represents the linear operator. L is the linear operator. So an object that satisfies the following two equations. So when you apply the linear operator on u1 plus u2, so it should be equals to Lu1 plus Lu2. And secondly, it should satisfy the equation L into AU. A is the any number and it should be equals to AL of U. So it should satisfy this equation. And for example, if L is applied on the alpha U1 plus beta U2, and it will be equals to alpha Lu1 plus beta Lu2 according to equation 1. And then so these are the condition for the linearity. So whenever you apply any linear operator on alpha u1 plus beta u2, it should be equals to alpha Lu1 plus beta Lu2. So it shows that if u1 is the solution, then Lu1 is equals to 0. If u2 is the solution, then Lu2 should be equals to 0. And then u1 and u1 plus u2 are the solution. Then if u1 and u2 are the solution, then alpha u1 plus beta u2 will also be the solution. So it is the general, you can say that it is the general superposition of two solution u1 plus u1 and u2. So and is the when you add up these two solutions u1 and u2, you get superposed solution alpha u1 plus beta u2. So these examples tells us that whenever we have the linear theory, we can add up the two solution or any number of the solution to get another solution. Okay, now we have another example of that is Einstein theory of general theory of relativity. Einstein general theory of relativity. Okay, so this theory is the non-linear theory. This is an example of non-linear theory. So how it is the non-linear theory? As the dynamical variable of this theory is the gravitational field. So here the dynamical variable is the dynamical variable of this theory is gravitational field. Gravitational field. So its dynamical variable is the gravitational field that describes that how planets move around different stars. So being a non-linear theory, you cannot add the gravitational field of different solution to find new solution. So it makes this theory more complex. So it is complex. And so in fact the classical mechanics mostly invented by the Newton and is also a non-linear theory. In classical mechanics, you know that the dynamical variables are the position and the velocity of the particle as determined by some forces. So there is no way to add the two solutions to obtain the third one. So we can say that the classical theory is rather more complicated as compared to the quantum mechanics. So we can say that the quantum mechanics is the linear theory. Now we will discuss that how quantum mechanics is the linear theory, as we have discussed that the classical mechanics is the non-linear. So here the quantum mechanics is the linear theory. Quantum mechanics is a linear theory. Is a linear theory. The main equation of the quantum theory is the Schrödinger equation, is the linear equation for a quantity called a wave function, which can be represented by psi. So psi is the dynamical variable, is a dynamical variable of Schrödinger wave equation. So the Schrödinger wave equation, it describes or determines the time evolution. The wave function is the dynamical variable in quantum mechanics. But the Schrödinger who invented it was not clear about its interpretation of wave function. Schrödinger wrote this equation, Schrödinger wave equation, in 1925, but he was not successful in explaining or interpreting the wave function. He was failed to interpret it. Later on, it was the Max Born. The Max Born interpreted the wave functions. He interpreted it. Who interpreted the wave function psi. Wave function psi. What he said, how he interpreted it, he said that wave function encode the probabilities. Wave function encodes probabilities. So he said that we can define the psi in terms of probabilities, that is psi amplitude square, that represents the probability. So in quantum mechanics we always talk about the probabilities. So wave function itself is nothing. Whenever we take the amplitude scale of this wave function, so we can interpret the wave functions. So it has this probability, this amplitude square of wave functions contain all possibilities, all probabilities about all solutions. So there we can say that the quantum mechanical theory is the linear theory. The linearity of quantum mechanics implies that it's a very simple, it has the simplicity, profound simplicity. So we can say that the quantum mechanics is simpler than classical mechanics. In quantum mechanics, solution can be added to form a new solution. A wave function depends on the time and may also it depends on the space. Wave functions depends on the time and also depends on the space. The Schrödinger equation is the partial differential equation, and so it takes the form like this one. So we can write Schrödinger wave equation as iota h squared partial psi over partial t is equals to h psi. Here h is the Hamiltonian operator. It is Hamiltonian operator, and you know that it is the operator of total energy, and so it is linear. So h a psi is equals to a h psi. And in the same way, when we apply the operator on two functions, that is on superposed solution, then we get h psi 1 plus h psi 2 according to the property of linearity. And so to check the Schrödinger equation, it is the linear. We can solve out the equations like L psi is equals to 0. So it means that if psi 1 and psi 2 are two different solutions to the Schrödinger equation, then their combination psi 1 plus psi 2 will also be the solution. So it was all about the property of linearity. That linearity tells us that how the linear theory are simple as compared to the non-linear theory. So thanks for watching. For more videos, please subscribe our channel.